Good evening. My name is Christian A. Landicho. My topic is about factor group or quotient group. What is factor group? Factor group is the factor group of a group G with respect to a special subgroup N called a normal subgroup. Can best be thought of a partition of the group G into classes which a group operation can be unambiguously defined cosets of a subgroup. We know what a normal subgroup is, and we have thought about partitioning of a group G cosets is about creating the cosets or just making the cosets. So the definition is the set of G mod H, set of all little g's, all elements of G operated with normal done with H. Now, this is the example using the definition. Our G is a set of 0, 1, 2, and 3. And the normal subgroup of G is 0, 2. Now let's complete the G factor. We're going to take right here from our definition, we're going to see that this H here, and for G and G, we'll do that for every elements. So we have 0, 1, 2, and 3. So now we're going to operate those out. We're going to have 0 plus 0 is 0 and 0 plus 2 is 2. Do that across here. We're going to get this for here. We don't need to write twice, so it becomes 0, 1 and 1, 3. What does G factor? So now we have the order. What is the order of G factor H? What is that order going to be? We have the order 2 because there are two cosets. There is 0, 1, 0, 2 and 1, 3. Now, let's think about why there are two elements. We have two elements because we have 4 in G, which is 0, 1, 2, and 3. And in H is 2, which is the 0, 2. 4 divided by 2 is 2. That's why we have two elements. Now you can see the name quotient group comes from it's just dividing it out. You're gonna see that you're gonna get 2 that's gonna hold true for all the other examples are going to have, so that's where the name quotient group comes from. This is the another example of factor group. This time we use the group G as the integers mod 16, and we're gonna have a normal subgroup H, which is 0, 4, 8, 12, just 4Z and 16, which we know is a normal subgroup of G. Now let's see what G factor of H will be. G integers mod 16 and H was 0, 4, 8, and 12. Now we have G here, and we're going to take the 0 from G and in our H. That's just going to be set of 0, 4, 8, and 12. Now we're gonna do the 1 plus H, which is just going to be the set of 1, 5, 9, and 13. We're just adding this one to 0, 4, 8, and 12. That's why it become 1, 5, 9, and 13. Now we're gonna do this 2 plus H and 3 plus H. We can also do this 4 plus H, but we don't need it because 4 plus H is going to be 4, 8, 12, and 0, which is the same with 0 plus H. That is 0, 4, 8, and 12. That's why we don't need the 4 plus H because it is the same. We also knew that we're gonna have 4 cosets in our factor group. And these are gonna be the 4, which is the 0, 4, 8, and 12, 1, 5, 9, 13, and so on. Now, you also notice that in our factor group, we have every element in our main group of G. So we have 0, 1, 2, 3, 4, 5, 6, 7, and so on. In our factor group, we have all the elements of our main group of G. And we knew it was gonna be an order 4. So we have 1, 2, 3, and 4. In this part, we're not talking about the cosets. We're talking about the order of cosets given. Now, let's look at a Cayley table of our factor group. Now, we have the Cayley table. We're going to operate this together, and you're gonna see that H is going to be our identity element. And then, we're gonna have, when we add this, 1 plus H and 1 plus H is equals to 2 plus H. You can work that out with each individual element. You'd find out that would be true. Now, you're also going to notice that 2 plus H and 2 plus H is equals to H because we are in mod 4. It's gonna be a mod 4 similar to what we had for our problem earlier. We had 4 plus H actually equals to H. We showed that we are going to get the elements 4, 8, 12, and 0, which we just knew is H, or 0 plus H. Now, quotient or factor group comes from in just dividing the elements of group G by normal subgroup of G, which is H.